Hi guys, this is Dylan at IQ Maths, and today I want to discuss sigma notation because I find that many students are getting very confused with this particular aspect of the math. So, in order to start this, we shall recall a few things first. Recall that a series is the terms of a sequence being added up. Okay, and the sequence is really arbitrary in this case because the sequence can take the form of a geometric sequence, it can take the form of a quadratic sequence, and it can take the form of an arithmetic sequence. And we should also recall some notation that we use before introducing sigma notation. The notation that you would have been introduced to rather would have been something called big Sn or sum to n, and this was just simply the sum of the first n terms of the series or sequence. Okay, so that was a notation that we use, and another way of writing this notation is as like this: term 1 plus term 2 plus term 3 up until term n. Okay, so now we will see that now we okay we will see that sigma notation and the sum to n notation mean one in the same thing. Same thing. The only difference between sigma and sum to n notation is that the sigma notation allows us to write a series in a more concise way, as it were. Okay, so I hope you understand the difference between sum to n and sigma. Yes, they're very similar. However, sigma notation has a slight advantage over the usual notation sum to n. So now let's actually get into the actual notation used when we use sigma. Okay, so with sigma, we'll have an integer on the top and an integer on the bottom. Okay. Now, sigma is really a function because if we recall, we know that a function has an input and has an output. So with sigma, we are inputting integers and getting outputs. So sigma is really a function. And therefore, this thing here is actually called the argument of the function. But for our purposes, we shall call this the general. Okay. We will call this the general term. And this whole thing is equal to a value, where the value is the sum of all the terms. Okay? You should think of sigma as another way of writing a series, basically. It really is just another way of writing a series, guys. Okay, so this is the last integer that is substituted, okay, that is substituted into the general term to generate the last term of the series. And the bottom guy here is the first integer that is substituted into the general term to generate the first term of the series. Okay, now if you guys do not know what integers are, then I shall explain, because it is important that we understand what integers are. So integers is just basically the set here. Remember, set is the collection of objects. It's the set of all the positive and negative whole numbers, including 0. So I'll repeat that. The integers are the set of all the positive and negative whole numbers, including 0. So it'll be like -3, -2, -1, 0, 1, 2, 3, etc. Now I just want to explain a little concept here. So let's do an example. If we have the summation from, let's say, I equals 1 to 5 of 3k. Okay, what this means is that, sorry, I should replace this with k. So the summation from k equals 1 to 5 of 3k. It means that, okay, it means that k goes from, k can take on values 1, 2, 3, 4, 5. Okay, so this is the first integer. And this is the last integer that we substitute into the general term to generate the terms of the series. This is the last integer. Similarly, if we have another case here, the summation from k equals -2 to, let's say, 3 of 3k, then k is really going from -2, -1, 0, because these are the integers, 1, 2, 3. Okay, and again, this is the first integer, and this is the last integer that we substitute into the general term to generate the terms of the series. Okay, so I hope this makes sense thus far. However, let's do a more concrete example to relate all the theory that we talked about in the above. So let's do an example. So evaluate the sum of the following. So we have the summation from k equals 1 to 5 of 3k. Okay, so relating the above theory the above theory to this example, we recall that this is the first integer, which will substitute into the general term to get the first term of the series. This is the last integer, which we will substitute into the general term to get the last term of the series. And this is the general term. And this whole thing will evaluate to some value, which is basically the sum of all the terms in the series. Okay, so let us do this. And we also know that k goes from 1 to 5, so k can take on values 1, 2, 3, 4, 5, as we saw above. So substituting the first integer into the general term gives us 3 times 1. And remember, sigma means sum, so it must add. Then substituting k equals 2, we get 3 multiplied by 2. And going on in this notion, we get plus 3 times 3, plus 3 times 4, plus 3 times 5, where we substitute the last term, or the last integer, into the general term to generate the last term of the series. So if we do a bit of simplification, we see that this yields 3 times 1 is 3, plus 3 times 2 is 6, plus 3 times 3 is 9, plus 3 times 4 is 12, plus 3 times 5 is 15. Now we can really think of this as term 1, term 2, term 3, term 4, term 5, right? Which is very similar to like S5, which was given as term 1 plus term 2, plus term 3, plus term 4, plus term 5, okay? So you see that the S notation and the sigma notation are very similar and they work hand in hand. So now we may ask the question, what type of a series is the above? Now, what I like to do is I like to write the series as a sequence. So I would write term 1, comma, term 2, comma, term 3, comma, term 4, comma, term 5. And we know that term 1 is 3, term 2 is 6, term 3 is 9, term 4 is 12, and term 5 is 15. Clearly you can see that we're just adding 3 to get to the next term. So 3 plus 3 is 6, 6 plus 3 is 9, 9 plus 3 is 12, 15 plus 3 is, 12 plus 15 is, not 12 plus 15, 12 plus 3 is 15. Okay, so we can see that we're dealing here with a arithmetic sequence because D, the constant difference between consecutive terms, is equal to 3, and clearly A is equal to 3. So here we have an arithmetic sequence in the context of writing the series as a sequence. So I'll just put slash series. So that makes sense. Now, what was the formula for the sum to n of arithmetic series? We know that sum to n, when we do not know the last term of the sequence or series, is given as n over 2 into 2a plus n minus 1 into d, where again a is the first sum of the sequence, d is the difference between consecutive terms and has to be constant, and n is the number of terms. So in this case here we are dealing with 5 terms, so we're dealing with S5. n is 5 over 2, a is 3, plus 5 minus 1 into d, which we know is 3. So let's work out the sum. So 5 over 2, 2 times 3 is 6, 5 minus 1 is 4, times 3 is 12. So this gives us 5 over 2 into 18. 2 goes into 18 9 times, and 5 times 9 is 45. Okay, so the sum of the first 5 terms is 45. And you will see that if you add this all up, you'll get 45. So the sigma notation works hand in hand with the old notation, sum